Hello everyone, this is Sanjay Rathi. How are you guys? Today we are going to discuss differential amplifier. Remember, this is one of the most important topics for any competitive exam, especially for what GATE engineering services. Okay, तो चलिए आइए देखते हैं what is differential amplifier. So this is differential amplifier. We are having the two inputs V1 and V2 and output is proportional to difference of the input, that is V1 minus V2. Now, after this session you will be able to solve this type of questions. If the differential voltage gain and the common mode voltage gain of differential amplifier are 48 and 2 dB, then what is the common mode rejection ratio? We will discuss what is the common mode rejection ratio. Okay, so that is an important topic. Now, second one, a differential amplifier has input V1 1050 microvolt, 950 microvolt is V2, then CMRR is 1000. What is the error in the differential output? If you have any idea, then try to give the answer in comment box. At the last, I will solve these two questions. Okay, don't try to mug up. I'm going to explain each and everything about the differential amplifier. Okay, now, first of all, what is the differential amplifier? It is a linear active device. We are giving the two signals V1 and V2. And ideally, what should be the output? It should be proportional to difference of the signal only, V1 minus V2. And then what is the constant of proportionality? This is AD, and AD is called what? Difference gain. So VD is called difference signal, V1 minus V2, and AD is called difference gain. So it is a linear active device. Now, but what, when we are designing this circuit, differential amplifier, then what will happen? V0 should be proportional to V1 minus V2, but actually we are adding this formula, AD/VD plus AC/VC. So this term is wanted term because it is a difference gain, it is a difference signal. What is this? It is unwanted term. This VC is called common signal. Common means average value of these two. Average means what? Suppose we are having the three boys. That age of the one is what? 20, age of the second one is what? 21, age of the third one is 22. Then what is the average of these three? So you can find 20 plus 21 plus 22 divided by 3. Okay, and you will get the 21 is the answer. So what is the average value? 21, and that is the common age. Common among these three is what? 21, and that's why this is called common signal. So what will happen in practical differential amplifier? Output is proportional to difference of the signal as well as what? Common of those two signals, that is V1 plus V2 by 2, average value or common value. Now it is unwanted. If it is unwanted, then what should be the AC? AC should be equal to 0. Ideally AC should be equal to 0. Common mode gain signal should be equal to 0. Okay, अब ऐसा क्यों होता है? Why this will happen? तो देखिए, first of all, we are going to design the differential amplifier by connecting one inverting operational amplifier. This is the inverting and this is the non-inverting operational amplifier, and we are using summer. Right? Now, try to understand. If suppose you are having adder or summer only, then if we are giving the two signal, then X plus Y, that is called addition. But if you want to get difference of the two signal, or if you want to subtract these two signals, to first of all change the polarity of Y by using inverting operational amplifier. We can change, or any inverting amplifier we can change. Y will become negative. So actually we are adding, but final result is what? Subtraction, X minus Y. So similarly, here we are giving the 0 degree phase shift, and that's why we are getting the A1 V1. Here we are giving the 180 degree phase shift. A2, the value of the A2 is negative. So here we are getting A1 V1. Here we are getting A2 V2. So what is the A1 V1 plus A2 V2? Right? Now, in this case, suppose A1 is 10, means it has 0 degree phase shift. A2 is minus 10, means it has 180 degree phase shift. Put the value. So what is the V0 will become A1 V1. So that is the 10 V1 minus what? A2 V2. A2 V2 is what? Minus 10 V2. 10 is common. So 10 will become AD. V1 minus V2 will become VD. And when we are comparing with this formula, here ADVD is present, but what about the AC? 0. and that is called ideal condition. So for ideal condition, magnitude of A1 and magnitude of A2 should be same. This is called ideal condition. What is A1? Gain of the non-inverting amplifier. What is the A2? Gain of the inverting amplifier, but magnitude should remain same. One is positive, one is negative. One is 10, one is what? Minus 10. Then we are getting the ideal condition. But practically what will happen? When we are choosing one non-inverting amplifier, one inverting amplifier, A1 and A2, the magnitude of A1 and A2 is not similar. Practically we are getting this type of value. Let A1 is 10, then A2 will become minus 9.9. Or sometimes A1 is what? 9.9, A2 will become 10. So it is not possible to make the magnitude what? Same. There is a slight difference. And because of that slight difference, we are not getting V0 is equal to what? ADVD. So what will happen then? If the magnitude is not equal, then we have to write like this. V0 is equal to A1 V1 plus A2 V2. And second equation is ADVD plus ACVC. This is for practical differential amplifier. Now we have the value of A1 and A2, but we have to find the value of AD and what? AC. What is the difference gain and what is the common mode gain? Now what we can write? Let this is the V1, that is the V2. So what is the difference between these two? V1 minus V2 will become VD. What is the common signal? V1 plus V2 by 2, that is called average value. Now we can write V1 in terms of VC and VD. So it will become VC plus VD by 2. And what is the V2? It will become VC minus VD by 2. Put these two equations 3 and 4 in equation 1. You will get A1 VC plus VD by 2 plus A2 VC minus VD by 2. This is the value of V1, that is the value of V2. From this equation, when we are taking common, what is the common here? VD. So I am just writing one equation here. V0 will become A1 VC plus A1 VD by 2 plus A2 VC minus A2 VD by 2. Now you can take VD common, it will become A1 minus A2 divided by 2 into what? VD. And when I am taking the VC common, it will become A1 plus A2. A1 plus A2 into VC. Then finally compare ADVD plus ACVC. So what is the AD here? A1 minus A2 by 2. What is the AD here? A1 minus A2 by 2. And what is the VC here? What is the AC here? A1 plus A2. A1 plus A2. By comparing these two, you will get this. So ye na, this was the question in what? GATE 2024. Find the AD, find the AC, find the CMRR in dB. So this is the AD, that is the AC. So in terms of A1 and A2, you will get the A1 minus A2 by 2, AC A1 plus A2, right? Now this is the standard formula. For this, from this formula, that this is the AD, this is the AC. Suppose I am again putting the, let the magnitude of A1 and A2 are equal. One is 10, one is minus 10. Put in this equation. So you will get AD is equal to 10 minus of minus 10 by 2. AD is 10. And what is the AC? 10 plus minus 10, it will become 0. So what is the ideal value of AC? 0. Again, if the A1 and A2 are equal, then AC is 0 and AD is what? 10. And that is called ideal condition. And this is the standard formula. Now, there is a one question, guys. Suppose one differential amplifier has AC 1 and second differential amplifier has AC 2.1. Which one is better? Which one is better? Give me answer in comments box. Then guys, remember, normally we are saying that ideal value of AC is 0. Practically it should be as low as possible because it is unwanted. In second case it is only 0.1, in first case it is 1, and that's why the second one is better. Second one is better. But guys, it is unwanted term. What is the wanted term? Wanted term is what? AD. So watch this one. If for the first differential amplifier, no doubt AC is 1, but what is the AD? 1000. If differential amplifier second, no doubt AC is 0.1, but what is the AD? Very small, 10. Then guys, what is the important term? Ratio of these two. When we are taking the ratio AD by AC, that is called common mode rejection ratio. If the ideally AC is 0, then common mode rejection ratio should be infinite, and practically it should be as large as possible. So for first case, what is the CMRR? AD upon AC, it is 1000. For second case, what is the CMRR? 10 by 0.1, that is 100. And for first one, it is high, and that's why the first one is better than the second one. So guys, remember, on the basis of AD or on the basis of AC, you can't compare the differential amplifier. You can compare the differential amplifier on the basis of CMRR. And that's why it is called figure of merit of any differential amplifier. Right? For example, when we are asking about the 12th result, normally we are comparing the two students on the basis of what? PCM, physics, chemistry, maths marks, not on the basis of math or physics or chemistry. PCM is what? Marks of PCM is what? Figure of merit to compare two students. Similarly, यहाँ figure of merit is CMRR. Now, to CMRR, so sometimes it is asked, what is the CMRR in dB? If it is in number, then AD by AC. If it is in given in dB, then CMRR in given dB is 20 log of AD by AC. Symbol for the CMRR is rho. So 20 log of AD by AC. So division is converted into what? Difference, subtraction. 20 log of AD log base to 10 minus 20 log of AC. That is called CMRR in dB. So this is about the differential amplifier basics. Questions like this. If the differential voltage gain, that is called AD, and the common mode voltage gain of a differential amplifier are 48 and 2 dB. Normally students are writing like this, 48 dB and AC is what? 2 dB. So what is the CMRR? They are simply giving the answer AD by AC, that is the 48 by 2, 24, and answer will become A. But this is wrong. So what is the right answer? My dear friends, it is in dB, and that's why you have to use this formula. 20 log of AD minus 20 log of AC means we have to subtract 48 minus 2, that will become 46 dB. This is the value of the CMRR, and answer for this question is C. Answer for this question is C, not A. Here we are making general mistake here. So remember, if it is given in dB, subtraction. If it is given in normal number, then division. Second question, V1 and V2 are the input voltages of instrumentation amplifier. The output of the instrumentation amplifier is normally, we are saying for what? Differential amplifier is to be, watch this, V0 is given as 100 V1 minus V2 plus 10 to the power minus 4 V1 plus V2 divided by 2. V1 plus V2 divided by 2. Now, what is given? The gain and the common mode rejection ratio. So guys, remember, gain, when we are talking about the gain, we are talking about the wanted gain. Wanted gain, so if suppose you are going to compare AD VD, this is the VD, plus AC VC. When I am going to compare, you will get the AD. This is called AD. So AD is 100. It is called wanted gain. And what is this? This is AC. It is AD. It is AC. So what is the CMRR? Ratio of this, or CMRR is 20 log of AD by AC. So AD is 100. AC is 10 to the power minus 4. It will become 10 to the power 6. 20 log of 10 to the power 6 is nothing but 6, 120 dB. So what is the wanted gain is what? 100. Always compare. This is the AD is the wanted gain, and AD by AC is called CMRR, and dB it will become 120 dB, and that is a very, very high value of CMRR. Watch this. AD is very high as compared to what? AC. 10 to the power 6 times high. It is a wanted term. It is unwanted term. So it is just near to ideal differential amplifier. Okay. So answer for this question is D. Then I have given this question at the starting. What is the answer for this question? In comments box. So write down the answer in comments box. In my coming session, I will solve this question. But remember, differential amplifier has an input V1, V2. So you can find the VD, you can find the VC. Now you have AD-VD plus AC-VC. Remember, just I am giving you the hint. This is the unwanted term and this is the wanted term. And what is the percentage error? This is the given now. What is the error in the differential amplifier? And answer is given in percentage. So always remember what is the percentage error. Unwanted term means error upon exact value, wanted term into 100%. So this is AC-VC upon AD-VD into 100%. And guys, as you know, AD by AC is CMRR. So what is the AC by AD? 1 by CMRR. What is the VC? Common mode signal. What is the VD? Difference signal. अब इससे ज़्यादा बताऊंगा तो ये solve ही हो जाएगा. Okay, so please write answer in comment box. What is the right answer for this question? And in next session, guys, I am going to explain differential amplifier by using op-amp. Operational amplifier. This is a very, very, very important topic for GATE exam and other competitive exams. Till then, this is the question, guys. This is the V1, that is the V2, this is RF, this is R1, this is R3 and R2. You have to prove for RF by R1 is equal to R3 by R2. This ratio, RF by R1 is equal to R3 by R2. AC will become 0 and CMRR will become infinite. AC will become 0, CMRR will become infinite, and finally you will get the answer. V0 is equal to RF by R1 into non-inverting terminal voltage minus inverting terminal voltage, and that is the output. But just to get this output, what should be the ratio? You have to check the ratio. RF by R1 is equal to R3 by R2. Then this is the output. But suppose if this ratio is not satisfied, then what will be the output? In next session, I will cover the differential amplifier by using op-amp. Till then, please get the command over this topic. Thanks for attending the session, guys. Most important, like the session, share the link of this session and subscribe my channel. If you have any suggestion, suppose you want to get some session on particular topics, so then write in my comments box or on my Telegram channel, that is Electronics by Sanjay Rathi. Link is given in description. Thank you for watching this session.